Now next topic, that is Coulomb's law. So with the help of large number of experimental observations related to the forces between charged spheres, scientist Coulomb represented the law which represent the force acting between two point-like charges. So he suggested this thing, the force, the electric force, it is also known as Coulombian force. The electric force between two point-like charges directly proportional to the product of these charges and inversely proportional to the square of distance between those two charges. And this force is along the line joining to those charges. Okay. Now, suppose as shown in the figure, we have two charges Q1 and Q2 which are separated by distance R. Both the charges are taken here positive charges. Okay. If one is positive, another one is negative, then also here we have to take the magnitude of charges, right? So at present, if we think about the magnitude of the force, then we have to take the magnitude of Q1 into Q2. Now see, if we have two charges Q1 and Q2 and the separation between these two charges, that is R, then the electric force between these two charges, F, that directly proportional to the product of these charges means Q1 into Q2. And it inversely proportional to the square of distance between those two charges. So we can write F proportional to 1 upon R square. So resultantly we can write F proportional to Q1 Q2 upon R square. Here the proportionality constant we can introduce, that is K. So resultantly we can write F equal to K Q1 Q2 upon R square, where value of K, that is 9 into 10 raised to 9 Newton meter square per Coulomb square. K, that is equal to 1 upon 4 pi epsilon 0, where epsilon 0, that is the permittivity of a free space. And if we make epsilon 0 as a subject, then we can write 1 upon 4 pi K. If we substitute here value of pi and K, then we will get permittivity of a free space, that is 8.85 into 10 raised to minus 12 Coulomb square per Newton meter square. Permittivity of any medium, that is nothing but the measure of the response of that particular medium to the electric field. So we can write the Coulomb's law in equation form as F equal to 1 upon 4 pi epsilon 0 Q1 Q2 upon R square. Okay. Now, with the help of this particular equation, one can give the definition of 1 Coulomb amount of charge also. How? Suppose we take the charges Q1 and Q2, both are equal, and that is equal to 1 Coulomb, and are separated by 1 meter. Then F will be equal to K, that is 9 into 10 raised to 9 Newton. So from this one we can say this thing, if two identical charges or two charges with equal magnitude are separated by 1 meter, and if the force between them is 9 into 10 raised to 9 Newton, then charge on each one, that is 1 Coulomb. or we can say each charge that is of 1 coulomb. Clear? Now, say if charge Q1 and Q2, these two are in some medium, means between these two, if some medium is there, then see if medium is not there, free space is there, then here the permittivity of a free space appears. But if medium is there between two charges, then very simple, we have to introduce here permittivity of that particular medium. So we can write the force between those two charges separated by distance r in any medium, that we can write 1 upon 4 pi epsilon q1 q2 upon r square, where epsilon, that is permittivity of that medium. Now epsilon upon epsilon 0, that is the relative permittivity of the medium, means permittivity of the medium with respect to that of permittivity of a free space. So that is relative permittivity. It is denoted by epsilon r. It is also known as dielectric constant of the medium. So from this one we can write epsilon, that is epsilon 0 k. So here if we introduce epsilon, that is epsilon 0 k, then we can write Fm equal to 1 upon 4 pi epsilon 0 k q1 q2 upon r square. But 1 upon 4 pi epsilon 0 q1 q2 upon r square, that is F, this one. Means Fm, that is F by k. It implies that if between two charges the medium is there, which one is with dielectric constant k, then electric force between those two charges becomes 1 upon k times then the initial one. Now, this equation that you have to remember, that is important for entrance examination. See, between these two charges, entire space is not filled with the medium, but small part is filled with the medium. It implies that between these two, the medium introduced, that is with thickness T, where T is less than R. એટલે થોડાક પાર્ટમાં medium છે અને પછી થોડોક part free space છે. અને medium જે introduce કર્યું એની thickness T છે, where T that is less than R. So in that particular case, we can write the equation of force, that is 1 upon 4 pi epsilon 0 q1 q2 upon r minus t plus t root k whole square, right? This equation is important for entrance examination. You have to remember it. That is not in your text, okay? So this one is Coulomb's law. Clear to all of you?